Hello, good morning, and today we are going to solve uh, October-November 2015 paper 1-2. Is the course is Physics 5054. Okay, Ji, on your screen we have question number 1. It says which is a scalar quantity? Scalar quantity is a quantity which can describe by its magnitude only. So mass, if you look at the list, the mass is a quantity which is a scalar quantity. For question number 1, A is the choice. Question number 2 is on your screen. He says, during an experiment to find the density of a stone, the stone is lowered into a measuring cylinder, partly filled with the water. Which statement is correct? The difference between the readings gives the density of the stone. The difference between the readings gives the volume of the stone. Yes, this is the answer. B is the answer. The difference between the readings of the measuring cylinder will give you the volume of this stone. B is the option. Okay, Ji, on your screen we have right now question number 3. Let me increase. The diagram shows a micrometer scale and which reading is shown. Let me increase its size so you can see it more clearly. Okay, so you're on your screen now. You can see. Okay, look at here carefully. Look at this horizontal scale. This is 0, 1, 2, 3, 4, 5, 6, 7, and this is 7.5. So 7.5 on the horizontal scale has been crossed by this circular scale. Now, note on your copy 7.5. On your copy, note down 7.5. Then we will look on the circular scale that which line coincides with this horizontal line. So this is 10, 11, 12, 13, 14th line is coinciding with this horizontal line. So I will take it as 0.14. 7.5 from the horizontal scale, and from the circular scale I got 0.14. Add both these numbers, 7.5 plus 7.5 plus 0.14, and the answer will be 7.64. The answer will be 7.64. So let's reduce its size a little bit. Okay. So the question was, what is the reading? So our answer is 7.64 millimeter. I hope you understand this. So the D is the choice for question number 3. On your screen right now, we have question number 4. He says, if we increase the size, what happens? Okay. A lorry takes 15 minutes to travel along a path PQRS. What is the average speed of the lorry? For finding the average speed of a journey, we need to know what is the total distance of the journey, and we will divide total time taken. So the total distance will be 8 kilometer plus 3 kilometer plus 5 kilometer. So 8 plus 3 will be 11, and 11 plus 5, 16. So total it will be 16 kilometer, and time taken is 15 minutes. But you know the options which are given in them, the speed is given in kilometers per hour. So we have to convert that time 15 minutes into hours. So how we will do that? 15 minutes, you divide it with 60, you will get the time in hours. I have done this on another paper. Let me show you the paperwork. Let me increase the size like 150. Okay, so here we go. On your screen you can see, I think you can see the total distance is we can increase the size further. Yeah, now you can see total distance is 8 plus 3 plus 5 equals to 16 kilometer. Average speed will be 16 divided by, but you will not take the time in minutes, 15 divided by 60 to convert it into hours. And so our final answer will be 64 kilometers per hour. So the option will be D. For this question, the option will be D, 64 kilometers per hour. Okay, the next question on your screen is question number 5. An apple of mass 0.15 kg and weight 1.5 Newton falls from a tree. At one point during its fall, the air resistance on the apple is 0.60 Newton upwards. What is the acceleration of the apple at this point? First of all, you know the weight 1.5 Newton will be acting downward. The air resistance 0.60 Newton will be acting upward. The resultant force you can get by subtracting these two forces. Once you have the resultant force, then you can apply Newton's second law of motion. F is equals to ma. We know the resultant force. We know the mass of the apple. Then we will be able to find out the acceleration of that apple. I have done this on a separate paper. Let me show you that. Right now on your screen, you can see question number 5. So the weight of the apple is 1.5 Newton. The force of the air resistance is 0.60 Newton. So the resultant force will be the difference of these two forces, that is 0.9 Newton. So apply the second law of motion, and F is equals to ma. So A will be F divided by m, 0.9, which is the resultant force, divided by the mass, which is 0.15 kg, and you get the answer 6 meter per second square. So the acceleration is 6 meter per second square. The option will be B. Question number 5. The option will be B. Okay, we are moving to the next question. Question number 6 is on the screen. At time t1, a stone is dropped from a stationary balloon. The stone reaches terminal velocity at the time t2. Which row gives the acceleration of the stone at time t1 and at time t2? You see, when you start falling at t1, when the stone started falling, there will be no air resistance. The only force acting on it will be the weight of the stone. So the resultant force will be equal to its weight. That's why the acceleration will be 10 meter per second square. But at T2, when it has reached the terminal velocity, the air resistance and the weight will be equal to each other. The resultant force will be 0. Because the resultant force is 0, the acceleration of the body will be also 0. So at T1, the acceleration will be 10 meter per second square. At T2, the acceleration will be 0 meter per second square. For question number 6, the choice is B. I hope you understand this. Question number 7 is on your screen right now. 4 of the gravitational forces that act between bodies in the solar system are described below. P, the force on the moon due to the earth. Q, the force on the earth due to the sun. R, the force on the earth due to the moon. And S, the force on the moon due to the sun. Which two forces are a Newton's third law pair, action and reaction? You know, the action and reaction pair will be between the same bodies. For example, if the earth applies force on the moon applies force on the earth. So both the bodies should be that pair should be same. The moon, for example, if earth applies gravitational field on the moon, force on the moon applies the gravitational force on the earth. So that will be a pair, and that is true. P and R, that is a pair. B is the choice. Question number 7, B is the choice. Earth applies force on the moon and the moon applies force on the earth. I hope you understand this. Question number 7, B is the choice. P and R are an example of the Newton's third law pair, action and reaction. Question number let me reduce size. Question number 8 is on the screen. The diagram represents the moon on its orbit around the earth. Which row represents the direction of the resultant force acting on the moon at the instant shown? This question comes again and again and again in papers. When you are moving in a circular path, the resultant force is always directed towards the center of the circle. So A will be the choice. A is the choice for question number 8. It's a famous concept on which many times questions come in paper. Question number 9 right now on your screen. He says, a student produces some revision notes on gravity. mass and weight. Which statement is not correct? He says a gravitational field is a region in which a mass experiences a gravitational force. That's true. Gravitational field strength has the unit newtons per kg. That is also true. Mass is a measure of the amount of matter. It is also true. Mass is equal to weight multiplied by gravitational field. It's wrong. Mass is equals to weight divided by gravitational field. The right formula is this. Mass is equals to weight multiplied by gravitational field strength. That's wrong. So D is not correct. He said which statement is not correct. D is not correct. For question number 9, D is the option. Okay, this question looks like it's a repeat question. We have seen this question in another MCQ paper. Also, two cylinders P and Q are made of copper. The height of P is twice the height of Q. The diameter of the P is half the diameter of Q. Which statement is, because I told you earlier also in another video that because both of them are made of the same copper material, so they will have the same density. It does not matter what is their dimensions. What are their dimensions? It does not matter because they both are made of the same copper. That's why they both will have the same density. The density of the cylinder P is equals to that of the cylinder Q. So that's the correct option. Question number 10C is the part. Okay, on your screen, the total weight of the load and the wheelbarrow shown is 600 Newton. What is the size of the force F needed just to fill the loaded wheelbarrow? Okay, so you see here, this is a wheelbarrow shown to you, and let me increase its size so I can explain to you. Okay, so this wheel, this is acting as a pivot. So load is here, the load is acting downward. The load is trying to produce a clockwise moment. The load is 600 Newton and it is trying to produce a clockwise moment. The distance, the perpendicular distance between the line of action of the load and the pivot is 70 centimeter. You will apply force here in the upward direction to lift the wheelbarrow. How much force is needed here? It is the question. The line of action of the force you will apply effort, its perpendicular distance from the pivot is 70 plus 50. It will be 120 centimeter. This force which you will apply in upward direction, it will produce anti-clockwise moment. For equilibrium, the clockwise moment and the anti-clockwise moment will be equal to each other. So we can find that F value very easily. Let me show you my working. So here I have done my working on your screen right now. Can you see this? Question number 11, the working is shown. Anti-clockwise moment is equals to clockwise moment. Force, which is the load. The clockwise moment is due to the load. That is 600 into 70. 70 is the moment arm. F, which we want to find out, 70 plus 50, because the moment arm is 120 centimeter. So take this 120 to the other side and make this F alone. You get 350 Newton. I hope you understand this. It's a famous question. Okay. So 350A. Question number 11A is the choice. I hope you understand. Okay, G, we are moving to the next question. A gas, question number 12. A gas is trapped inside a cylinder by a movable piston. The length of the gas column is 20 centimeter and the pressure in the cylinder is P. The piston is pulled out a distance 30 centimeter so that the length of the gas column is now 50 centimeter. The temperature of the gas does not change. What is the new pressure of the gas? Remember, he's talking about the pressure of a gas, and he said that the temperature is kept constant. If the temperature is kept constant, then we can apply the formula P1V1 equals to P2V2. And the volume of the gas can be found by the product of the cross-sectional area and the length of the gas column. volume is equals to cross-sectional area multiply length of the gas column. P1 V1 equals to P1 P2 V2. Let me show you my working. And you know, we know that P1 V1 equals to P2 V2. P1 into V, in the place of V1, I can write area multiply length 1. In the same manner, in the place of the V2, I can write A cross-sectional area multiply L2. You know, cross-sectional area in both the cases was same. Cross-sectional area of the cylinder remains the same. So A and A from both the sides will be cancelled. So P multiply length 1 equals to P2 multiply length 2. P multiply length 1 is 20 equals to P2 multiply length 2 is 50. So if you make P2 alone, the 50 will go on the other side. It will go downstairs. So we will have 20P by 50. So it will be 2 by 5P. It will be 0.40P. So the option is A. I hope you understand this. Question number 12, the answer is A, 0.40P. Okay, so we are moving to next question. Question number 13 is on your screen. The base of a rectangular storage tank is 2 meter by 3 meter. The tank is filled with paraffin to a depth of 3 meter. The density of the paraffin is 800 kg per meter cube, and the gravitational
Bluetooth mode. The Bluetooth device is ready to pair.
Gravitational field strength. The paraffin, the density of the paraffin is 800 kg per meter cube, and the gravitational field strength is 10 Newton per kg. What is the pressure at the bottom of the tank due to the paraffin? You know, paraffin is a liquid. The pressure of the liquid we can find by the formula. We call it the hydrostatic pressure. The formula is rho GH. Rho stands for the density, G stands for the gravitational field strength, and H stands for the depth of the liquid column. Okay, so I have done this working, and I can show you that. Okay, this is the working. Question number 13 is the pressure is equal to rho GH is equals to density is given 800 into G stand into 3 is the height or depth of the water. So 24,000 pascals. C is the choice. Question number 13, C is the choice. Okay, G, I think you understand it. Question number 14. A person throws a stone so it follows the path shown in the diagram. In which position does the stone have the most gravitational potential energy? The gravitational potential energy depends upon the height of the object from the ground or from a reference point. So the maximum height the object gained is on the position B. So on the position B, the body will have the maximum gravitational potential energy. For question number 14, the answer is B. For question number 14, the answer is B, because there the body is at the highest point. Okay, everyone. So now you can see question number 15 is on your screen. Question number 15 is on your screen. A piston of area 10 centimeters square is pushed slowly into a very large cylinder containing gas at a pressure of 10 Newton per centimeter square. The pressure of the gas remains constant as the piston moves a distance of 0.10 meter. Okay, you know what is the force of the gas on the piston and what is the work done by the piston on the gas? You know, the pressure is given in Newton per centimeter square. The area of the piston is given in 10 centimeters square. So what we will do, we know the formula, pressure is equals to force divided by area. So I can calculate the force by rearranging the formula. So force will be equals to pressure multiply area. So you will get the amount of force. Once I know the force, then we know that how much distance the piston moved. I know the force, I know the distance moved, the work done can be calculated by the formula work done equals to force into distance. So we can calculate both force and the work done by the force. I have done this on a sheet. Let me show you. Okay. So pressure 1 is given 10 Newton per centimeter square. Area is given 10 centimeter square. So put the values in the pressure formula. Pressure is force divided by area. The pressure is 10. The area is 10. So F1 will be 10 multiplied 10. That will be 100 Newton. Work done can be calculated by the formula F into D. F is 100 Newton and the distance is 0.10 meter. You multiply them, you get the answer 10 joules. So the choice is C. Here, let me show you. Here you might have observed that the unit of the area is centimeter square, the unit of the pressure is Newton per centimeter square, but the distance traveled is in meters. So when I put the area and the pressure in the same formula, the units of the area were consistent with each other. They were both centimeter square. So that's why we got the force in newtons. So don't get confused that they are not consistent with each other. Question number 15, the C is the choice. I hope you understood. Question number 16, a gas is in a sealed container of constant volume. The volume is not changing. The gas is heated and the pressure of the gas on the walls of the container increases. You see, the volume is not changing. It's a very important rule. Then the pressure and the temperature, they are directly proportional to each other. How do the particles of the gas cause this increase in the pressure? When you raise their temperature, because the volume is not changing, when you raise their temperature, actually they start moving faster. So when they move faster, their Coulomb frequency increases with the walls of the container. One, their frequency of collision with the walls of the container increases. Secondly, now they are colliding with more force. They exert more force when they collide. That's why the pressure increases. So the option, they expand? No, the molecules don't expand. They hit each other more frequently. They hit each other, no doubt, but that is not the cause of the pressure. They hit the container more frequently. Yes, that is the answer. They vibrate faster. That's not has nothing to do with the pressure. They hit the container more frequently. That is the actual cause of raising the pressure of the gas inside the cylinder. Question number 16, C is the choice. Okay, on your screen now you can see we have four thermometers given. The diagram represents four thermometers. Which thermometer has the greatest sensitivity and which thermometer has the greatest range? Sensitivity means that in the same length of the thermometer, we have the least range. That will be more sensitive. So you see, it is going from 0 to 25, its range is 25. It's going from 30 to 40, its range is 10. It is going from 0 to 250, its range is 250. It's going from 100 to 300, its range is 200. This one, the Q1, it has the same length like the others. It has the same mercury in it because the bulb size is the same. The rest of the things we are assuming are same. Because it has the least range, just 10 centimeter. So we believe it has the most sensitivity. The distance between each degree is larger here. So it has it is the most sensitive. The Q is the most sensitive. And the most, the largest range is R because it has you see, it's going from 0 to 250. So the range is 250. So R has the largest range, and let me reduce the size. Yeah. Now you see, just it. Okay. Greatest sensitivity, Q has the greatest sensitivity, and the greatest range, R has the greatest. So C is the option for question number 17. C is the option. I hope I have made my point clear. Okay, on your screen we have question number 18. Okay. Question number 18 is on your screen. Some of the liquid in a dish. evaporates as shown in the diagram, which molecules leave the liquid and which molecules in the liquid have greater average kinetic energy. So the molecules which have left the liquid, they have the highest energy. And the liquid molecules have greater kinetic energy before evaporation. So it looks like the A. For question number 18, A is the option. The molecules that leave have the highest kinetic energy or energy, and the molecules in the liquid have greater average kinetic energy before evaporation. After evaporation, their kinetic energy decreases, average kinetic energy decreases. So A is the option, question number 18, famous question. Question number 19 is on your screen. Let me show you. Okay. Question number 19 is on your screen, and an insulated beaker contains 300 grams of water initially at 30 degrees centigrade. Water at 100 degrees centigrade is added until the temperature of the mixture reaches 50 degrees centigrade. The specific heat capacity of water is 4.2 joules per gram per degree. How much water is needed? Okay, so here we have two. So suppose we have two beakers, and in them we have two different waters. In one beaker, we have 300 grams of water and its temperature is 30. And in another beaker, I have water whose temperature is 100 degrees centigrade, but I don't know how much is that water. What I did, I mixed them together. I put them in a single, in the same beaker. So one sample of water was hot and the other sample of water was cold, relatively cold. One sample, the sample number 1 was at a temperature of 30. The sample number 2, the water was at 100 degrees centigrade. But when you mix them, they reached a temperature of 50 degrees centigrade. So the 300 gram water, which was at 30 degrees centigrade, its temperature changed from 30 to 50. And the sample number 2 water, whose mass we don't know, we know its temperature was 100. Now when it's in the mixture, its temperature has become 50. So from 100, its temperature has dropped to 50. Now one sample has gained energy and the other sample has lost energy. The energy gained by one sample is equal to the energy lost by the other sample. And you know the energy gained or energy lost, which involves temperature change, we can find that that heat or that energy. The formula is mc delta theta. I have done this calculation. Let me show you that calculation. Okay. So here on your screen, you can see that working is showing the heat lost and heat gained, they both are equal. Heat loss, because it involves temperature change, can be found by the m1c delta theta 1 equals to heat gain can be found by m2c delta theta 2, because both samples are pure water, so their specific heat capacities will be same. C value on the right side, on the left side is same, so C and C will be cancelled. So the formula will become m1 delta theta 1 equals to m2 delta theta 2. Here delta theta means change in temperature. The sample 1's mass 1 is 300 gram and the change in temperature is its temperature change from 30 to 50. So the change in temperature is 20. For sample number 2, M2, we don't know. That is the question we need to find out. Its temperature change from 50 to 100. So there is a change of 50 degrees in the temperature. So if you make the M2 alone, that will be the answer. Final answer will be 120 grams. There is a negative sign with it, but just neglect that negative sign. And so the M2, the sample number 2, whose temperature was 100 degrees centigrade, its mass was 120 gram. B is the option. I hope you understand this question. So question number 19, B is the answer, 120 gram. Okay, so we are moving to the next question. He says, which statement is correct? Okay, let me see this side. He says, which statement is correct? Infrared radiation cannot travel in a vacuum. That is, which statement is correct? Infrared radiation cannot travel in a vacuum. That's wrong. Infrared radiation cannot travel in solids or in gases. It's also wrong. Infrared radiation can only travel in a vacuum. That is also wrong. It can travel in vacuum, but it is not only in a vacuum. Infrared radiation can travel in a vacuum and in gases. That is the right answer. The most right answer. The best possible answer is this. Infrared radiation can travel in a vacuum and in gases. D is the option. For question number 20, the D is the option. Okay. So on your screen right now, we have an echo sounder produces ultrasound of frequency 24 kHz. The ultrasound travels in a water at a speed of 1.5 kilometer per second. What is the wavelength in water of the ultrasound of this frequency? We know the speed, kilometers per second, 1.5 kilometer per second, and we know the frequency, 24 kilohertz. And the question is, what is the wavelength? So you know the famous wave equation, V is equals to F lambda. V is equals to F lambda. So lambda, which is wavelength, is equals to V divided by F. So we will have 1.5 kilometer per second divided by 24,000 hertz. The answer will be 6.25 expo minus 4 kilometer. So to convert the kilometer into meter, we multiply it with 1,000. The answer is 0.625 meter, which is approximately 0.63 meter. So the answer is option A, 0.63 meter. Question number 21, the answer is A, option A. I hope you understand. Okay, Ji. On your screen right now, we have question number 24. An object is viewed through a converging lens. The diagram shows the path of two rays from the top of the object to an eye. How does the image compare with the object? You know, if you look at this object, the rays are going like this, then it becomes parallel to the principal axis. This ray is going to the optical center. If you prolong them behind the object with dotted lines, they will intersect here. So most probably the image will be formed here. Its arrowhead will be here. The image will be formed here. So your eye is here. So when you look through the lens, you will be able to see this image. This image will be upright and it will be large. It's a virtual image. The image will be upright and larger. So question number 22, the option will be B. For question number 22, the option will be B. I hope you understand. He says in an experiment using a ripple tank, plane wave fronts arrive at a plane surface. Which row correctly describes the waves after they are reflected from the surface? You know, when the waves are reflected, only their direction changes. Their speed do not change. Their wavelength do not change. Their frequency do not change. Only the direction of their propagation changes. So there will be no change in the speed of the wave and there will be no change in the wavelength. So D is the option. The speed of the wave will be the same and the wavelength will be the same. D is the option for question number 23. Okay, we are going into question number 24. And 24 is on your screen. You can see that question now. He says, which statement about the red light and the blue light is correct? The red light has longer wavelength than the blue light, because whenever we write that in a code, we say Roy G Biv, ROYGBIV, Roy G Biv. So because the red is on the top, it has the largest wavelength. Blue color is below red, so it has the wavelength of the red is longer than the blue. So B is the option, sir. Question number 24, B is the right option. Okay, on your screen we have question number 25. A loudspeaker produces a sound wave of frequency 50 hertz. The amplitude of the sound wave is increased. What is heard? When you will increase, you have not changed the frequency, but you have increased the amplitude. When you will increase the amplitude, the loudness of the sound will increase. The loudness of the sound depends upon the amplitude. If you will increase the amplitude of a sound, its loudness, you will hear a louder sound. But because you have not changed the frequency, the pitch will be same. So we will hear a louder sound of the same pitch. So B is the option. Question number 25, B is the option. Okay, so we are going to next question. Question number 26 is on your screen. An ultrasound scanner produces an image of an unborn baby. Here you can see the part of the scanner. And how does the scanner form an image? This part of the scanner, it emits the ultrasound, and it also the ultrasounds are reflected from the fetus, and those reflected ultrasounds are detected by the scanner, and by that it makes the image of the baby. So from the ultrasound reflected by the baby. So C is the option. Question number 26, C is the option. Question number 27, the sound from the siren of a ship. Let me increase its size. Clear. The sound from the siren of a ship is reflected by a cliff. An echo is heard by a sailor on the deck of the ship 4 seconds after the siren is sounded. The speed of the sound in air is 320 meters. How far from the cliff is the ship? So, for example, here is the ship, and here is the cliff. So from here, the sound waves went, reflected from that cliff, and came back. So, the sound waves traveled first from the ship to the cliff, and then from cliff back to the ship, and the man was able to hear the echo, the reflected sound. The speed of the sound is given here, 320 meters per second, and the time between the actually blowing of the siren and hearing the echo is 4 seconds. So during that 4 seconds, the sound was traveling. So let us find, first of all, the distance traveled by the sound in 4 seconds. So it will be 4 into 320, and you will get the answer. And let me show you. I have done this calculation on the paper. Okay. So the distance traveled will be equals to speed multiplied time, that is 320 multiplied 4, so 1280 meters. That's the distance traveled by the sound wave. But his question is, what is the distance between the ship and the cliff? Distance between the ship and the cliff, this 120 meters, this is the distance in which the sound traveled from the ship to the cliff and from cliff back to the ship. So that 1280 meters divided with the 2, and then you will get the distance between the ship and the cliff. So 1280, and you divide it with 2, so we got 640 meters. So the distance between the ship and the cliff is 640 meters. For question number 27, the C is the option. 640 meters. C is the option. I hope you understand. Okay, on your screen we have question number 28. His question is, which material can be picked up by a magnet? Very simple. Iron is a magnetic material, so iron can be picked up. For question number 28, C is the option. Okay, Ji, we are moving to next question. Question number 29 is on your screen. He says, which row correctly name an electric conductor and an insulator? Very simple question. Electric conductor, iron is electric conductor, insulator, rubber is an insulator. So B is the option. Question number 29, B is the option. It's a very simple, straightforward question. No googlies in it. Question number 30. A positively charged insulated metal sphere is brought close to an uncharged insulated metal sphere. You see this sphere, let me increase its size so I can explain to you. Okay, this sphere is positively charged and this sphere has no charge, it's neutral. Because this has positively charged, it's positively charged. So the electrons of this sphere all around on the whole sphere, wherever there are free electrons available, they will be attracted to this left corner. So on this left corner, we will have negative charges. And on this, because the deficiency of electrons will be produced, so here we will have positive. So here we should have negatives and here we should have positives. Let us reduce which diagram correctly describe this. I think the B is the correctly shown diagram. So for question number 30, I think the B is the right diagram. The B diagram is correctly showing the charge distribution. Okay. The diagram shows the magnetic field around wire X which carries a current into the copper. The arrows on the field line show the direction of the force on. I told you that whenever you will put a magnetic compass in a magnetic field, whenever you will put a magnetic compass in a magnetic field, the magnetic compass north will always align itself in the direction of the magnetic lines. Actually, the north of the magnetic compass points in the direction of the magnetic line of forces. So these arrows which are shown on the diagram, they are actually showing that if you put a north pole here, what will be the direction of the force on that north pole? That arrows, those arrows which are on the circular, the circles, the concentric circles which are drawn around that wire, and the arrows on them, the arrows are actually showing the direction of the magnetic field, which means these arrows are showing the direction of the force on a north pole. Question number 31. A is the answer. It's a little conceptual question. Okay, question number, right now on your screen, you can see question number 32. P and Q represents two parallel straight wires carrying current into the plane of the paper. P and Q exert a force on each other. Which row shows the force on the Q? Okay, look at here. P is a conductor and Q is also a conductor. The P is represented with the cross, the Q is also represented with the cross, which means we have two parallel conductors and in both of them the direction of the current flowing is same. If you have two parallel conductors and the direction of the current in both of them is same into the page, both of them the current direction is into the page because the current has been shown by a cross, then they both will attract each other. If you have two conductors and they are parallel to each other, the current direction is same in them, they will attract each other. So which arrow shows the force on the Q? D is the option. For attraction, the P should apply a force on Q towards itself. So D is the right option. D is the right option. Question number 32. D is the option. Okay, question number 33 is on your screen. A power supply of 18 volt is connected to three resistors as shown. What is the potential difference across the 2 ohm resistors? See, the strategy is very simple. First of all, find what is the total or combined resistance of these two. They are parallel to each other, so 1 by R equivalent is equal to 1 by 8 plus 1 by 8. So find their equivalent resistance. Then their equivalent resistance will be in series with this 2 ohm. Then I will find the total resistance of the whole circuit. I know the EMF of the battery. If I know the total resistance of the whole circuit, we can calculate how much current will come out of the battery. The current which will come out of the battery, the same amount of current will pass through 2 ohm resistor and go back to the battery. Remember this thing. The current which will be coming out of the battery, the same amount of current will be going back to the battery and through the 2 ohm resistor. If I know that current, if I know the amount of current flowing through 2 ohm resistor, I know the resistance, I know the amount of current, I can calculate what is the voltage drop across the 2 ohm resistor. Let me show you my working. Okay, so here first of all, I 8 ohm and 8 ohm, two resistors which were connected in parallel to each other, these two. So let me find their equivalent resistance. 1 by R equivalent is 1 by 8 plus 1 by 8. So R equivalent will be 4 ohm. This, their combined resistance 4 ohm. This, their combined resistance is connected with the 2 ohm resistor in series. So the total resistance of the whole circuit will be 2 plus 4 plus 2 equals to 6 ohm. We know the EMF of the battery and we know the total resistance of the circuit. So divide the EMF with the total resistance of the circuit, you get 3 amps. So the current coming from the battery will be 3 amps. The current coming from the battery, same current will be going back to the battery. And the same current will be flowing through the 2 ohm resistor. So voltage of the 2 ohm resistor can be calculated easily. V is equals to IR. I know that the current flowing through the 2 ohm resistor is 3 amps. And the resistance of the 2 ohm is 2 ohm. So multiply them, you get the 6 volt. So we now know that the voltage drop across the 2 ohm resistor will be 6 volt. So the choice is C. Let us go back to. So the choice is C. For question number 33, the choice is C. It involves calculation. I hope you have understood. Question number 34 is on your screen. He says an immersion heater is labeled 224 volt and 120 watt. What is the current in the heater when it is connected to a 24 volt supply? We know the power, we know the voltage, the current is question, very easy. You remember the formula. Power is equals to IV. P equals to IV. If I know the power, I know the voltage, I can calculate the value of I. Let me show you the calculation. Okay, yeah, here we go. On your screen, you see P is equals to IV. I will be P divided by V. The power is 120 watt and the voltage is 24 volt. And divide them, you get 5 amp. So the answer is 5 amp. For 34, the option is B, 5 amp. Okay, we are moving to the next question. Let me reduce the size. Question number 35 is on your screen. Electric power cables transmit electric energy over large distances using high voltage, alternating current. What are the advantages of using a high voltage and using of an alternating current? Remember, high voltage is used because when you make the voltage high, the amount of current decreases, and by doing this, what happens? The power loss in the transmission lines or energy loss in the transmission lines is reduced. To increase the voltage and decrease the voltage, we need an instrument which we call transformer. And transformers automatically work only in the alternating current. So why we are using high voltage and why we are using alternating current? At high voltage, there is less energy or power loss in the transmission lines. And why we are using alternating current? Because the transformers can be used to increase or decrease the voltage. So D is the option. For question number 35, D is the option. Okay, Ji. Question number 36 is on your screen. He says, which particles are emitted by the hot filament of a cathode ray oscilloscope, CRO, and which type of field is used to accelerate them? from the hot filament, electrons are emitted, thermonic emission. Electrons are given. And to accelerate them, we provide them with an electric field. You know, you might remember in that CRO that in the front of that cathode we put an anode at a very high voltage. So we provide electric field to accelerate those electrons. So particle is electrons and type of field you provide is electric field. A is the option for question number 36. I hope you understand. Okay ji. The diagram shows an electric device X connected between a 6-volt alternating current supply and a 12-volt lamp. The lamp is seen to glow with normal brightness. What is the X? Here you are providing alternating current and the voltage is 6 volt. This is the primary side. On the secondary side, we are getting 12 volt. The voltage has increased. So what is the instrument we use to increase the voltage? Transformer. Transformer is the instrument which has the ability to increase, step up the voltage or step down the voltage. In this case, it has stepped up the voltage. So it's a step up transformer. For question number 37, D is the answer. Okay, on your screen, a little bit tricky question. 38, question number 38. In the circuit shown, all lamps are identical. Lamp P lights with normal brightness. Switch Y is closed and lamps come on. Which row indicate the brightness of the lamp? You see, here, when there is only one before, and in the first situation, there was only one lamp connected, lamp P only. This switch was open. And it was at normal brightness. Then what we did, we closed this switch. When you will close this switch, this is a relay. This will become magnetic, electromagnet. It will attract this toggle, and this switch will be also closed, and the current will also start flowing through this portion. And due to this, what will happen? These lamps will also switch on, but they are parallel to P. Because you have connected them in parallel to P, the whole resistance of the circuit will drop. The important thing is that the voltage drop on this branch and the voltage drop on this whole branch is same, and they both are equal to the voltage of the battery, EMF of the battery. The voltage drop in this branch is equal to the EMF of the battery. The voltage drop in this whole branch is equal to the EMF of the battery, because they are parallel to each other, plus they are parallel to the battery. So here we have a single lamp which is getting the voltage equal to the voltage of the battery. But here we have two lamps. They combinedly getting the voltage of the battery, but individually they will be getting half of the EMF, half of the EMF. Half of its voltage drop will be equal to half of the EMF, and the voltage drop across R will be also half of the EMF. So it is getting full voltage equals to EMF, but they are individually getting voltage which is half. This whole branch is having voltage drop equals to the EMF of the battery, but they are connected in series with each other. So half of the voltage EMF will be taken by Q and half of the EMF will be taken by R. So voltage is half. So P will be on a normal brightness and they will be dimmer as compared to P. So P will be normal, Q will be dim, R will be dim. Okay. So what is the choice? Question number 38. I think the B is the choice. Question number 39 is on your screen. Let me please this size. Okay. A radioactive isotope C14 emits beta particles. A sample of this isotope is left for a period of time that is equal to its half-life. Which two quantities decreases to half of their initial value during this time? When half-life has passed, nuclei of or the atoms of that carbon 14 will become half. Half of them has decayed. Plus, the decay rate, the amount of radiation, the decay rate will also become half. Okay. So the number of the carbon-14 nuclei and the decay rate, they will become half. C is the option. Question number 39. C is the option. On your screen, you know, question number 40. The Geiger Marsden experiment. A beam of alpha particles is fired at a very thin sheet of gold foil in a vacuum. What is deduced from this is a famous experiment, and in this experiment they bombarded a very thin gold foil with alpha particles, and what they found, most of the alpha particles went straight through the gold foil and very few of them were deflected or bounced back. From there he made a conclusion. He deduced that most of the atom is empty, but in the center of that atom there is a small nucleus. So he basically discovered the nucleus. Nuclei are much smaller than the atom. D is the option. So for question number 40, D is the option. So that's it for today. Today, you know, we have done October, November 2015, and it's paper 1-2. It's an MCQ paper of Physics 5054 course. I have tried my best uh, to explain the concepts. I hope it is helpful for you, and please try hard, study hard, and I believe, God willing, you will succeed and you will get good grades. So thank you very much, everybody, and have a good day.